Hi everyone, we're going to use the comparison test to determine whether each series is convergent or divergent. And basically what we're going to compare it to is 1 over n. So if you take the limit as n approaches infinity over 1 over n, we know that this equals 0, and 0, absolute value of 0 is less than 1. So that means it would be convergent. And if it's not then we know that it's divergent. So basically, we're going to look at this and look at the general form. We have a sub 1, a sub 2, and a sub 3. So my general form basically is 1 over 2n, and then you square it. So this would be basically 1 over 4n squared is our general form. And then, therefore, if you look at the comparison, we want to compare it to 1 over n. And what we notice is that whatever number we put in for n, it's less than this term. This term is going to be less than this term. So that means it's going to be convergent. And we're going to do 4 more problems so you can get a better idea of what we mean. So the next one we have is this one. And the general term for this one is going to be 1 over n cubed plus 1. So you look at that and plug in your numbers, your little index numbers here, and you see it follows that pattern. And so we're going to compare it to 1 over n. If it's less than 1 over n, then it's convergent. If it's not, then it's divergent. So if you plug in 1 in, let's plug in, say, 2. If you plug in 2, you get 1 over 9. If you plug in 2 in this, you get 1/2. We know 1 over 9 is less than 1 over 2. So we know that for this one, in general speaking, I just did an example here, this is going to be less than or equal to 1 over n. If it equals 1 over n, then it would still be convergent. So this is going to be convergent. So we're always comparing it to 1 over n. Okay, the next one we have is this one. The general term for this one, or our nth term, would be n over n plus 1. So we're going to compare that to 1 over n. And you can just plug in some numbers. And when you plug in numbers here, for example, if I plug in 2, I'm going to get 2 over 3. And if I plug in 2 into this one, I get 1 over 2. Well, this is bigger than 1/2. So in general, this is going to be greater than or equal to 1 over n. So that means it's going to be for all n. And therefore, this series is divergent. All right, the next one, we have this one. The general term for this, my numerator, I can write this as 5 over 5. So I can see the pattern better. So we know it's 5 over n plus 1, or n plus 2 actually, since we're starting with a sub 1 and a sub 2. So there's my general term, and when I compare it to 1 over n, any number I put in here is going to be greater than or equal to 1 over n. So this is for all. And this is how you can write for all, upside down a, for all of n. So this is divergent. And I think I have one more. And it's this one. And the general term, these are odd numbers here. So this is going to be, the general term is going to be 1 over 2n plus 1. And I think this should have been 11. So let's put 11 there. Now I'm going to compare this to 1 over n. And if I plug in numbers in here, just plug any old numbers, they're always going to be less than or equal to 1 over n for all of n. So this is convergent. And that's how you do the comparison test. Thank you and have a nice day. Bye-bye.